Welcome everybody. My name is Ruth Slavid. I'm your chair for the day, and welcome to this PiP seminar on education buildings and school architecture. I will just talk through a little bit of administration. For those of you who have been here before, it is as it has been before, so sorry if you've heard this before, but for everybody who's new or for those who don't remember, please do notice that you have two functions on your screen, a Q&A function and a chat function. In terms of the chat, we would love to know where you're from, because we typically get delegates from all around the world. So if you're somewhere very, very exotic, let us know, but also let us know if you're somewhere in the UK, even if you're just up the road from me in Finchley in North London. Put that into the chat. And there's also a Q&A function. And after each speaker's spoken, you will have the opportunity to ask questions. Please put your questions into Q&A. Don't put your questions for the speakers into chat. And welcome to Steve from Hull. Put your questions in Q&A, and we will have a short Q&A session at the end of each speaker's presentation. So I think that's most of the admin. I'm really pleased to see you here. Welcome to those of you who've just joined us in the last few seconds. We're talking about a subject which is obviously very important. Education is the making of all of us, and apart from our homes, our education buildings are really our first experiences of architecture. And in the current circumstances, we're seeing two changes, I think. One in the way that our cities operate, and one in the way that education operates. I think we've been asking questions about both of those over the last few months, so that makes this even more relevant. Each of our speakers are going to talk for about 15 minutes, and then we'll have about 5 minutes of questions. And we will have a break in the middle of this session when I suggest you just walk away, don't terminate the call. But that's really, I think, enough from me. I'm now going to introduce our first speaker, and I am delighted to introduce Ron Bakker, who is an architect, of course, and founding partner of PLP Architecture. And in particular, Ron is the author of a RIBAJ book called Smart Buildings, which was published earlier this year. And I'm sure once you've seen his presentation, you'll want to buy the book. And I'm pleased to tell you that there is a special offer at the moment, that instead of the usual price of £45, it's available for only £40. And RIBAJ's publishing the details of that under the chat function. So I'm going to hand over to Ron. As I said before, if any questions strike you, particularly during his presentation, rather than waiting until the end, then do put the questions into the Q&A. And Ron, you've got the floor.
Thank you very much, Ruth. I'll share my screen with you. Good morning. I am also in North London. But it doesn't seem to matter much where I am these days. Life just goes on. We actually are in the office as much as we can, because we are absolutely sure that we need to be together physically to be able to function properly. But we're running on about 80% if we're not all together. And I'm sure that's the same in education. My son's in uni and he's not having a great time, just because there's no contact. He might as well be somewhere else. So I'm going to talk about architecture, smart architecture, and the very fast-moving technological world we are living in at the moment, and how exciting that is for architects. And we are not specialist educational architects. We do some academic buildings here and there, but most of our more interesting building projects do have an angle that's very educational. It happens all the time. This is our office, one of the most educational spaces you'll see on the screen today. People learn all the time, and I'm assuming most of you are architects. It doesn't matter if you're not, but if you're an architect, you will know that you are able to deal with a great variety of subjects that are often very, very far removed from each other. And that's what we do, architects, on a daily basis. Pretty much, we're somehow relating things to art and to ecology, economics, acoustics, neuroscience, many issues, and we're actually very well placed to connect all these different strands of stuff that's happening in the world at the moment. For me, I'm going to do a brief history of architecture. This is my most important architectural shot, but this explains everything really. It's you need to make places for people to come together, feel comfortable, be able to communicate with each other. And you don't need very much for it. You need some fresh air, you need a bit of shelter, perhaps some climate control, you need some good furniture, comfortable furniture to sit on, and you need coffee. And really with that, you have created a place. In the history of architecture, we've been working with nature to start with, using natural materials when we started, and finding shelter. Pretty soon we started learning from each other and passing on the knowledge about buildings from one to the other. And some of those incredible buildings from the very past did not have much technology behind them or science, but they were based on deep learning from generation to generation. Around the time of St. Paul's Cathedral, we started involving science as part of the architecture. This is one of the very first buildings whose structure was described in terms of mathematics, and a very, very cool moment in history, because we started to be able to describe things from a mathematical perspective rather than just trial and error. Big thing. We learned a lot when we started developing new materials. And this is one of my favorite buildings. It was built actually before all the historic architecture around it in Amsterdam. It's Bakker's open air school. It's a whole lecture by itself. Then in the 60s, 50s and 60s, we were starting to understand social sciences better, how people relate to each other, what they need in terms of communication and feeling well. And that is already 60 years ago, but that's coming back with a vengeance, and making buildings that are really to do about the relationships between people and how they communicate with each other has actually sort of become our headline activity at the moment, despite all the sustainability, all the material technology, and I haven't really even talked about architecture, whatever it is by itself, but we're looking at these aspects. And what I enjoy very much is the idea that you make spaces that combine all these different influences. When we did the Rothermere Institute of American Studies in Oxford, it was very much a sustainable building. It was to do with temperature, airflow, shading the sun, cooling the building down with thermal mass at night. It was very much to do about daylight and making a space that people were feeling comfortable and happy with, acoustics, but really it was about books and about people finding quiet places to study. And the image on the right actually has all of these aspects in it, filtering the light, the cooling system. The books are part of the thermal mass of the project. It's very, it goes very deep. So working on these educational projects always meant that you're dealing with big spaces for lots of people moving around. When we did university work in Amsterdam, that was our main obstacle, was how do we move all these hundreds of students in 3 minutes from one classroom to the other. And that was our biggest problem. Of course, not something that you realize then in the end of the building, but these issues are now increasingly better dealt with technology, and that is helpful. So a lot of these new ideas are thought up in places that might be the first step after university, like ThinkSpace and Imperial College, where young entrepreneurs are working side by side with their patent lawyers and their bankers to get new ideas onto the market and grow their company. But it's a place of learning. And the current stage of the world, I'm going faster and faster because time is moving on. is all about innovation shock. And this is not a personal term, this is an economical term, which means that huge things are happening in technology, as they did in the 1920s, the last time around, that forward the economy and that give a massive new impulse. It's an exciting time, as you can see. Not only the boy in all the kit, but his friend is also excited to see what's happening to him. There's about 7 types of progress that we are going through at the moment. They are at the moment being treated separately. There are inventions, there are disruptions happening at the moment to the world because we have invented things. The next stage, which is about to start in about 5 years, is the one of convergence, which is super exciting because these 7 are going to mix one by one, and we're going to connect these very opposing forces. You know, we're going to be able to download a copy of our soul. Who knows? This is a wonderful image by Andreas Gursky called Amazon, and it is a warehouse in a very dry and empty area in the States. It's full of stuff, and the stuff is all totally unorganized, it seems. If you look carefully at the beautiful picture on the wall in an art gallery, you'll find that there's no relationship between different types of books, or it's a total utter mess if you are a human being. But for a digital system that is used to find all these objects, it's not a mess at all because everything is logged digitally. So this is going to be a kind of marker for what happens in the future. We can create an enormous mess and still be able to find things. And it's the digital connections that are going to make us function as human beings in communication with each other, but also in communication with the data that we need. So quickly, a project we did in Amsterdam, which is an office building. And you know, a lot of people are learning there too. And it was the first building that really was designed to be a digital part of the digital world. It was also designed after the realization that not all people are the same. Actually, people working in a building like that are all very different, have different requirements, different ways of communicating, different places where they feel comfortable and happy and be able to be very productive. And so we made all these different kind of places for people to choose from, and they were choosing because they are connected to the building through a digital system, through their smartphones, and the building knows them a bit. The building understands what they like, what they don't like, and together they function incredibly well, we must say. The project is very green. The project has, you know, it started as a sustainability project, but pretty soon it became a smart project. And in terms of management and capital cost, you know, optimization, this all works beautifully. And we're still learning from this project, which was finished about 5 years ago. But for me, most importantly, the digital tools used in the building are very much part of people's enjoyment of the project. People feel really well in this building. Absenteeism has gone down massively. People are not feeling ill at the end of a day's work. There is a lot of excitement for the project. The main tenant, Deloitte, finds that more people are interested in joining them, which is you know, hugely important to them, because talent is all they really need to have have a future. And people are happy typically. And you walk, I walk the building, I talk to people, some that I don't know, younger, older. I always ask them, how does the building make you feel? And nobody talks about the technology. Nobody talks so much about the sustainability and how much energy they've used, but people talk about the space, the light, quality of the light, the acoustics, and the fact they can come together, you know, and coming together is really what these educational buildings and work buildings are for. And when we designed the Francis Crick Institute together with HOK, that was the principle of the project, was to make a great big space where people could meet, and then all their separate workspaces, the laboratories and the write-up places were positioned around this atrium. We were physically forcing people to talk to each other, people who perhaps wouldn't have met otherwise. And we did this because we had learned from speaking to the scientists that a lot of the big advances in science and technology, and as much as in medical technology as in any other technology, come from moments where two people whose fields slightly overlap talk to each other and have an idea in common. And that sets off a whole new trend in their thinking that will often lead to great advances in technology. So that's a kind of an incredible notion, and to be able to design buildings around that notion is really very, very, very rewarding. It seems to work. It's a busy place at the moment. This year is a strange year, of course, and even stranger for the people working at the Crick. And you can kind of imagine. So one of the projects we're currently working on is headquarters for a big tech company in Moscow, the kind of Russian Google. And we've been talking for years since the first stroke of a pen about how they function together as a group of people and how they want people to learn as part of being part of their company. And we've created a building that encompasses a place to communicate, but also a place that's intimately connected through digital means. So everything, all the climate and all the communication and all the work and the data, everything is connected through a very central place that organizes all of these streams of data. It's a kind of it's a nervous system, I suppose. We can talk about that. The building itself does the things that we just talked about in Edge and Crick. It's very open on the inside. It's a very wonderful, comfortable space, lots of green, great daylight. But there are also quiet places where you can hide, and you'd be amazed about how many people actually are looking for a quiet place. And office space, as we have known it for the last 50, 60 years, really isn't doing very well in terms of making great places for people to work. We have a long way to go. So these notions of connection, digitally or physically within spaces, are starting to overlap. And they are overlapping with mobility, they're overlapping with ecological issues, with biodiversity, they're overlapping with energy networks. All of these layers can now be somewhat more connected than they have ever been in the past. And we're developing master plans for a big university in India, in the south near Chennai. This connectedness is the basis of our master planning, connectedness between people, but also between natural systems and buildings. And the picture becomes very complex, but I think it's in this complexity that one can really create quality, almost in a way that is kind of turns into the background once a building is finished. So we're looking to connect issues of mobility and accessibility. It's a large piece of farmland. There is a very strong connectedness between people and farming in India. It's very close to people's minds, actually, and why not include that in a place to learn? There's a big water issue in the area, which is part of it. We're creating all types of spaces for different activities around the campus. Everything happens in the same place, and people live there, people study there, people visit, and the campus is connected to the rest of the world through a digital connection. So technology and energy and the ecology are connected as well. I'm using the word connected far too much. I think obviously it's all about this this relationship, there are new trends starting to happen in education as much as they are elsewhere in the world. We are not seeing the traditional academic buildings, no more departments. That's a thing from the past. Departments are a way of separating ideas, whereas in fact our future is about these ideas coming together. The idea of library is actually exactly the same, only it is a much richer place. It's largely digital. It can be accessed from anywhere rather than from a specific building. And the learning spaces themselves have to be incredibly flexible, because the life of a student moves from one space to another, just as the workplace in the edge. These are spaces that are actually finely tuned to the type of learning that is happening. And so we can make better places than we have for this. The master plan is taking shape. It's you know, we're trying to then find ways architecturally to make this look pleasant as well as complicated. And as always, it's an overlap of ideas. So the smart part of the campus has overlaps between different focuses. There's a campus-wide focus, a learning focus, and a student focus. Those three have overlaps, but somewhere in the middle, there's the analytics part where they come together. And we're hoping that with the control of the data that this place creates, we can predict scenarios, and we can predict the way we can work with qualities for the future. I think I'm almost there. There's one puzzling shot I always kind of bring into these things, because I've been told quite often that our future as human beings is about the coming together of emotions and data. And I can't explain this, but I think there is something in there that might help us start our future.
Thank you very much indeed, Ron. That's really interesting. Nice to know that the entire history of architecture only forms about 5 minutes of your presentation. And quite rightly, you're looking to the future more than the past. Now, possibly in keeping with this, I've had a very philosophical question come in, and I'm not sure it's particularly for you, but why don't you have a go? Peter Hitchens says, we used to teach people how to think. Now we teach them what to think. Do you agree? And I guess the other question that I'll append to that is, it's interesting when you talk about education buildings that, of course, the people using education buildings are the people who are going to be using workspace buildings a few years in the future. And I wonder whether you think the education buildings will affect their workspace, or whether workspace should be feeding into education.
Yeah, great. Great questions. I think the first question is very much about the teachers. You know, teachers have always been in the position of telling their students what to think and what to do, and that's their role. You know, and it's not just the passing on of data, because that can be done in different ways. You know, you can sit somebody in a corner with an interesting book, but talking to that person maybe about the issues in the book, but about much more, is better education, especially early in life. And I think that doesn't disappear. I think we learn much better from people talking to us than we do from reading a book. As much as I love sitting in the corner with a book, I think it's the human engagement that makes for great learning. That won't go away, I think. I think it is still a space issue, because you need to come together. This is how I started. You know, we now know that learning online is not quite as great as learning in person, and that we need to hold on to that notion, because that we need to make places for the future that function like that. When I showed the project in Amsterdam, that was an interesting project, because the reason we were doing that was not so much to just produce designs for education buildings, but also to build in a flexibility for the organization of the university. That their biggest risk was real estate, and the reason their risk was associated with real estate was that their educational systems changed so quickly that their buildings would never catch up with it. And on the one hand, they needed buildings that were so flexible you could change them all the time. On the other hand, they needed buildings that they could ditch, you know, that they could sell. And to be able to sell them, they had to be able to function as office buildings as well. So these buildings were designed with 2 or 3 purposes in the start, and that is complicated, but I think that's sort of what we need to do in the future. Because you're saying people are learning in school and then they take it to their workplace, but actually in the world of the future, very often the workplace is only 50% of their week. The rest of the week still has to be filled with things like education. So we will find that our schools are going to be used in the evening for evening classes. People with a lot of time on their hands and hopefully a lot of interest will keep learning. Learning is not going to stop. We know that it doesn't, but it shouldn't stop. Even if you never get a job, you'll keep learning.
Well, thank you, Ron. And yes, I think you're quite right. We do physically need to come together, but I'm hoping, and from the numbers attending, I think it's definitely the case that these webinars are very much a next best thing. What the technology does allow you to do, as I said before, is to post questions to the speakers in the Q&A section. And the more questions that you pose, the livelier a debate we can have. I think now I just have to thank Ron very much for certainly having woken us all up. As I said, if you want to learn more, there will be a recording available, but you also have the opportunity to buy his book, which you can find details of under the chat. But we're going to move on to the next speaker now, who is Paul Stallan, partner at Stallan-Brand Architecture. And he is going to be talking to us about one particular project, which is the Broomlands School in Scotland. So, hello.
Hello, Ruth, thank you. I'll just try and share my screen. Ron, could you?
Ruth, I think Ron's screen's still up.
Yeah, Ron, if you could, thank you very much.
Right.
Thank you, Ruth. Can everyone see that presentation? Yes.
Yes.
Great.
That's great. We've got a notification over the front there if you want to just get rid of that. Thank you.
Okay. Thank you very much, Rory. I'm going to talk to you today about school topology and two schools, actually, a primary school and a secondary school. And I want to start by essentially explaining that in Scotland, the curriculum that we respond to as architects is called the Curriculum for Excellence. And the Curriculum for Excellence is essentially pedagogy which places the student at the very centre of the experience, recognising that students effectively learn in different ways. And that is essentially quite a radical concept, especially as we move through school into the secondary context. So I'll demonstrate how we've responded to this rich kind of education theory, if you like, in relation to the settings that we have created for that learning experience. There's a philosopher that has essentially mapped out, the theory of multiple intelligences, how children, and all of us, effectively learn in different ways through music, through socialization, through physical activity. So essentially what we need from early years through our whole education experience is essentially to look at environments that stimulate us. 90% of a child's brain development happens before the ages 5. That formative time is so critical in terms of the development of character and resilience in young people. And so the environments of early years preschool are as critical to a learner as they are as they get older. And you can see the way that the environments have changed are from the chalk and talk ideas of the sort of formal classroom with a teacher at the front and students behind to what we're looking at and exploring is a much more complex kind of dynamic setting where there are different ways to learn throughout the day and different ways to work with your teachers in collaborative ways, and especially in relation to external learning. In Scotland especially, external learning has not been featured enough in the education programme, unlike in Scandinavian countries. Now, this was Broomlands, the existing school which we took on at the beginning of the project. You can see, and it's pretty miserable and it has very limited access externally. Essentially, it was a cellularised, compartmentalised space where teachers weren't communicating, they were isolated, and the children were kind of essentially contained within a class with no external awareness. And essentially what we've been looking at over the course of 10 years is looking at the classroom environment, not to create compartments in the cellular classroom structure, not to create open plan, but to create a hybrid of spaces that you can choreograph throughout the day in multiple ways, so that throughout the life of a week, the environment can change. You can team teach, you can externalize, you can do one-to-one teaching, and it becomes this kind of really dynamic landscape and spatial experience, which kind of builds a much richer place for a student to effectively grow and become an individual in their own terms. And so we've looked at various permutations of how that space that comes together. And taking that idea, the DNA of a series of classroom clusters, we've looked at various contexts in the Scottish borders, and we looked at the site in Kelso for this school called Broomlands, and we began to basically orientate and develop the cluster forms to respond specifically to an exact site, and thinking about the uniqueness of that location. I mean, the borders is just a spectacular area of Britain. The scenery, the landscape are really just beautiful, really beautiful. And so all of our projects that have been working with the Scottish Borders local authority respond in dynamic ways to the unique settings. In this instance, it was a kind of perfect green field surrounded by trees on all sides. And our building was very much about keeping low to the ground and creating canopies that the children could basically come out of their classrooms and externalise, and that relationship between inside and outside was broken down, and the whole connectivity with the place and the town was reinforced. You can see the site plan here. I mean, it's an idealised setting, orientated in a sort of north-south axis with east and west facing classrooms. And figuratively, the building begins to pick up on some of the features of the Borders landscape in terms of its scale, in terms of its roof structures, in terms of the kind of the landscape forms, its signature, the idea of the kind of boats, the upturned metaphor that Morales used in the Scottish Parliament, the idea of external classrooms, and just to create an experience which is thrilling in a way. And this is the entrance to the building, and the building had to speak to the community because the school is not a school, it's very much a community building. And they wanted a really expressive entrance where parents could gather when they're picking up their children in the rain. Obviously it rains in Scotland, and a building that really invited and said, we're open, come in. And you can see the scale in terms of the relationship it has with the ground and the trees and the sky. And on its south aspect, we created an overhang which creates almost like a terrace. There's a community football pitch in front of this, which the community can gather at the weekends and watch a game either of hockey or of football. And so it's very much set within a context of the community. So that's the easy one, primary. Primary is quite, in some ways spatially fun to respond to as an architect, and there's a level of kind of openness and playfulness that you're allowed to kind of explore. It becomes much more difficult when you start to look at secondary education, and this is where I really want to make some critical points. When we started to look at secondary education in the Borders, this was the first school that we looked at in Galashiels. And again, the site and the context is spectacular, but you've got a classic 60s slab block here. Galashiels got a very poor HMI report. Essentially what was happening was the entire school was departmentalised. So teachers were in staff bases and didn't speak to each other, and the students trudged up and down corridors between departments. And you know, I remember drawing this little drawing when I came back from, even despite the landscape it was in, it had a yard, which, you know, which literally a concrete space where the children were contained within. So, you know, there was no breakout space, there was no dynamic space for kind of socialisation. And again, you see, like the primary school, this compartmentalising of, you know, subjects. So to be clear, in Scotland, what we have is 5 learning stages from early years primary to secondary, all the way through to, you know, sort of 6th year where you kind of enter into employment or college or university. And what we basically did was we deconstructed these learning stages and understood where the challenges were. So we had become expert in early years and primary education buildings, but we wanted to really provoke and challenge a debate on the secondary topology, which the government has been promoting. There are 2 exemplar projects which the government promotes. And these stages here, the transitions, are where learning fails and where pupils have real challenges between primary and secondary, between early years and primary, and when after you leave school to go into college. So we wanted to start looking at a much more blended experience. These are the 2 exemplar plan topologies that the government has been promoting, which we have resisted. The fingers option and the courtyard option. And you can see, essentially, again, they haven't changed for 50 years. You know, as a form of plan, it partitions education, and it's still, despite the curriculum being quite progressive and saying student-centred learning, the environment, the architecture works against that intercurricular working. You know, so what we've fundamentally done in the development of a new type is radically reimagine how the school spatially comes together. So departmentally, what you had previously was all these compartments, you know, between modern studies, geography, language, maths, chemistry, etc. All partitioned, not speaking to one another, and the students really suffering between the stresses of having to really be focused on every one of them without any overlap. I mean, my daughter studied modern studies, English and art, and you know, one day she came home with 3 S's in feminism because none of the teachers were sort of combining or talking to one another. So our view was that secondary education should be much more like primary. It's harder to manage because of the complexity and, you know, in terms of, you know, the subjects that you become study, but it's not impossible. And what we began to look at was, could we create a secondary which was a sort of glorified primary school in a way where that connectivity. So what we have created is basically a secondary school with no classrooms. You stay in your learner stages. You basically stay in your learner stage, and you are within a gigantic studio space. And within that studio space, there are all different types of settings. You know, there are one-on-one spaces, there are classroom spaces. It's much more. It's much richer. And so we effectively took that curriculum and that learner progression plan and mapped it spatially into a new school diagram to create a different topology. And we expanded that as a building out into a landscape. So the learner stages relate to the landscape as you progress through, all the way through to you get to 6th year, where you can study car mechanics, carpentry, etc., or, you know, gardening. You know, there's all sorts of ways in which, you know, that can respond. And importantly, these buildings increasingly are becoming much more public. And what we developed was, you know, from instead of the curriculum being from 3 to 18, basically our buildings are 0 to 100. We want everybody, you know, to be able to access the buildings. So our campuses are now becoming intergenerational. The only spaces that we're effectively securing are the early years in terms of, you know, locking them down, keeping students safe. But everything else, in terms of, we have a cook school, we have art and craft, all of these spaces are accessible to the public all day, not just at night and not just at the weekends. It's a civic building that happens to be a school. and it's much more radical. In terms of the kind of learning stages and the clusters, you know, as I say, not having classrooms, essentially create a big funky studio with all of these incredible, you know, different, you know, spaces and areas where people can come together. And in Jedburgh, one of the challenges was there isn't a flat site, and the whole of the borders, apart from a couple, you know, one was Broomlands, but the topography is just, it's so hilly, and Jedburgh as well, it's a very, you know, it's a medieval, you know, town with a 14th century abbey, so we were very, very challenged, if you like, in how we were going to respond. And what we looked at was, you know, every school in Scotland through the kind of hub process at the moment is tending to be a box. And so we looked at deconstructing that box horizontally and taking these ideas that we've developed and integrating them into the landscape. So here's this built diagram of the learner stages all the way through to the upper years, and then the community function to the side and the internal street. And all of that relates back to the landscape. So as you terrace up in those kind of spaces, you have direct access out into the landscape. You can see some of these images of our model here, and just the scale and you know, the beginning of an architectural idea. And Jedburgh was home to a geologist called Hutton, who discovered the tectonic plates. It's called, you know, he termed this Hutton non-conformity, and we developed this idea of Jedburgh essentially looking at almost being stratified like a geological kind of you know, feature. So you can see how we've developed the architecture and series of spaces, you know, as we progress through. So we've not had the opportunity to go into the space and take, you know, good photographs yet, but the idea is that not only in plan do we have that dynamic space, but also in cross-section. Everybody can see everybody, the clusters connect to the social space. Your mum and dad might be in here taking a course, or your grandmother, you know, doing a yoga course, and you're all connected. It's an extension of the high street. Just flick through these images. And I just wanted to kind of end there by saying that essentially the second critical area of brain development is in adolescent times. Essentially the brain is going through what's called a pruning stage, where essentially the plasticity of the brain is kind of crystallizing. You're cutting away things that you don't need, and that's, you know, it explains, you know, the challenges that young people have in this time. And it's the whole reason that we're essentially creating this new topology is in Scotland is to address the well-being agenda, because for too long now the priority has been on attainment, and the stressors on children are just significant. So it's proven that if you prioritise well-being over attainment, that actually attainment goes up. And we're working with the mental health minister and on this new philosophy, if you like, of well-being. And just to say, I mean, this is very personal to me, because this picture here, this is my son on the left. My son took his own life 3 years ago because of his, you know, the challenges he had at school, because of that institutionalized setting and the kind of you know, the challenges that presented. You know, he never felt that nurture that he had in primary. The nurture agenda in secondary school is non-existent. We need to create environments that basically help and support young people. I mean, at the moment, the scenario of poor health, mental health in young people is just you know, unacceptable. 1 in 4 teenage girls self-harm, and the biggest killer of young men is young men. So this is an area which is really you know, important, and I think it's an area that's been overlooked, and I think I'm not entirely sure what the pedagogy is in England, but I think it's really critical that we address this. Thank you.
Thank you so much, Paul. That was fascinating, and thank you for sharing all that with us. I think, as you know, part of the purpose of the seminars is to talk both about big ideas and about the nitty gritty. We had at least one person responding and just saying how lovely the primary school in particular was, with the big canopy, and wondering how you managed to avoid getting that value engineered out. But I suspect that's a long answer. The other thing that a couple of people have questioned is about acoustics, you know, lovely open flexible spaces. But how do you deal with acoustic issues? And we are running a little late. So if you can just answer that question briefly, and then I think we'll go on to our next presentation.
Okay, thank you. Yeah, acoustics is actually quite simple to address. We've created much more generous floor to ceiling heights and wider spaces, but we do have a lot of acoustic baffles, and we do still have classrooms in some of the small. We've created a series of small spaces that are focused and are acoustically appropriate, if you like. But yeah, no, we can overcome the acoustic component, but it is something you have to address. It really is. It is critical to make it work.
That's really fascinating. Thank you very much. I think we could talk about this for a long time, but we don't have infinite time. So we are going to go on to our next presentation, which is the last one before we have a break. And that's going to be Allan Hurdle from Stamisol. And I think we can all agree that on the one hand, we want to talk about really exciting and dynamic ideas for our education buildings. On the other hand, it's also essential that they should be safe. So I think the fact that Allan is talking about fire safety is really pertinent now. Over to you.
Okay, right. Hopefully you can all hear me.
Yes.
So today what I want to do is just give you an overview really of the Stamisol Safe One building facades for a building high-rise, or sorry, a vertical wall system. Myself, I'm the technical consultant for Stamisol Safe One, and I'm looking to raise the profile of A2 membranes as part of the vertical wall system. Myself, I've been involved in the HVAC, heat ventilation, air conditioning markets for over 32 years, specialising in HVAC products and specifically for smoke control. I'm technical consultant for the Smoke Control Association, and I'm dedicated to help raise the bar on the importance of smoke control with A2 membranes. With A2 membranes fitted to buildings. So effectively, what I wanted to do is obviously present to you why a vertical membrane should not be confused with a damp course or a roof membrane. And we will look at the technical specifications of a membrane and why an A2 is better than a class E and B when supporting cladding on a vertical wall system. And hopefully we'll also be looking at the independent tests that should be carried out to confirm an A2 classification. It is important to understand what a vertical membrane offers compared to damp-proof or waterproof membranes, as membrane itself is a generic term for a product, so it does not differentiate between the different types. You have damp-proof and you have waterproof membranes, but these are not part of a vertical wall system. However, the name membrane still falls within this family. And these are considered as low risk in times of fire, and therefore are exempt from being a Class A2 S1 DO vertical wall system. So the characteristics of a building membrane are they've got to be UV resistant, they should be water resistant, windproof and breathable, all in the one product. An example of this structure would be the human skin or a Gore-Tex coating. And part of the product's aim is to keep the thermal insulation blocks dry and therefore functional. A2, or in the UK, limited fire membranes, assist in reducing condensation build-up in the building structure. It's there to help keep the insulation values high and therefore contribute to the building energy saving programme. It can at times be used as an open face for cladding with 50mm gaps that act as an architectural feature. The membrane, when installed behind cladding, helps create the closed system as proposed in Approval Document B, Part 4. Without a membrane, this slide shows what could happen to insulation and the risk of damp and health problems associated with damp spores. Bacteria could pass into the building via the cavity or the air bricks and finally into the occupier's airspace. In this scenario, the cladding was placed directly over the thermal insulation and fungal infestation took place, resulting in the outer wall system having to be stripped and refitted with new thermal blocks and then a membrane and the final cladding. Given that a Class A2 S1 DO is now available, Approval Document B should be changed to only specify A2 in support of a wall system. And the reason being that at times Class B membranes will burn at high temperature and give off toxic fumes. And poor fitted membranes with incorrect cladding will contribute to fire spread. So when changing cladding, it makes sense to remove the Class E or B at the same time. We propose that Approval Document B Part 4 is modified to include A2 membranes, and membranes should not be exempt. By raising the profile of a Class A2, architects can now specify these, and we should not accept that low price will over safety. This slide gives technical data that an A2 membrane should adhere to and the performance levels it should meet. So these will meet the specification of an A2 wall system, specifically with the life-saving part of Euro A2. Dame Judith Hackett has been quoted many times as saying, given the clear evidence that continues to emerge of concerns about high-rise building safety which go beyond the ACM cladding, we believe there is a moral obligation on the industry to step up to different approaches. And over the next year, she aims to recognise and accredit those organisations that are stepping up to deliver improved practices. Nick Coombs, MBE and a member of the National Fire Chiefs Council, said that of 500 buildings inspected, 65% had safety failures. Now, these failures covered a multitude of problems found within a building, but it does show the size of safety concern that needs to be addressed. When I started on this slide, originally there were 250 existing buildings. Now we're showing upwards of 457 buildings that need to be reclad. It has now been established there could be up to 2,000 buildings with incorrect cladding. Well, how many buildings have membranes that could catch fire or give off toxic fumes? The IFSEC Global Report in July 2020 estimated that over 500,000 people across the UK are living in buildings with combustible cladding. So if cladding has to be removed, why not remove the Class B or E and replace with the A2? So one of the things we ask is, what are the attributes and what should an A2 mean? Well, it should give off the limited combustibility. It should be fully functional up to temperatures of 250 degrees versus the current 120 degree for a Class B membrane. It should come with a DOP or a declaration of performance and therefore meet all the standards of the EN specification. Following Grenfell, it was clear that a change in building safety was needed for security and safety of residents and occupiers. The use of an A2 exceeds the current requirements of Approval B and C for permeability, weather control and condensation, plus giving this added protection on the outside and into the inside of any building. A2 facade breather membranes are for use in vertical wall insulation behind closed or partially open facades and range screens. It is rated to an A2 S1 DO to EN 13501 Part 1, and it is UV resistant for partially open facades with a 50mm gap or a maximum area of 50%. The expectation is that customers installers will have some experience of fitting vertical wall systems, and they should hold a valid CSCS skill card to level 2 and an NVQ for the building industry. One of the features that architects looked at for the design in high-rise building is obviously to make it look cosmetically good. At present, there is only Class A2 in black available, but it still can make a very good architectural feature and looking. For me, it is often asked how the membrane sits in front of thermal blocks, and this slide shows how the thermal block is attached to the wall, followed by the membrane, and then by the final cladding. Another question is, well, what do the classes mean? Well, the 4 classes of specification are shown above. An A2 is considered to be non-combustible, such as glass, where A2 in mainland Europe is also called zero combustibility, but here in the UK, an A2 is called a limited combustibility. Class C to D are combustible categories. S1 is smoke capacity or operation and means the limited smoke as an S1. DO means hot droplets, or DO means no hot droplets. So the A2 S1 DO is the ideal solution for vertical wall systems membranes. There is an in-house fire test which was completed on 4 classes of membrane, being F, E, B and A2. Now this video is available to view on the Stamisol website, www.stamisol.com. And you will see from the video that Class F ignites and burns quickly. Class E ignites at lower flame levels, giving off toxic fumes, and these are a problem. With Class B igniting at high temperatures, but will give off fumes. The Class A did not ignite with limited fume development. Another test that we felt needed to take place was an independent test, and this was carried out by the FPL or Fire Products Association. And we asked them to carry out an independent test on 3 types of membrane, being E, B and Class A2. And the video, again available on the Stamisol site, demonstrates their results and shows that a Class A2 performed far better than an E or B in smoke and droplet development. You then have to decide or understand the sorts of tests that an independent test should carry out. Tests need to be carried out by an independent tester. It is no good a company saying our products were tested in accordance with. They should be tested at an independent test house in line with EN 13823 2010 and EN 13501 Part 1 to meet the Euroclass A2. And a test house needs to carry out all the above tests shown on this slide. This slide, for those who'd like to see it, shows the typical installation process for a vertical wall system. It shows the insulation thermal blocks, the thermal, membrane, and the final cladding. So what are the types of building materials that a membrane can be attached to? Well, they can be attached to weatherboards, to concrete blocks, bricks and cement boards. They should be fixed utilising aluminium battens for tightness and giving minimum air pockets, and use a necessary Stamisol glue to hold one membrane against the other at no more than 50mm distance. So what is a summary of what an A2 S1DO membrane should ask for? Well, the above are points that you should consider when reviewing and specifying a vertical membrane. They should first of all go for the A2 S1DO, be water resistant, independent tested, with no fire ignition. You should ask to see a copy of the Declaration of Performance with the independent test certificate, with the UV guarantees, and ensure it meets the UK building regs and approval documents. There is a full presentation that we will be holding on the 15th demonstration again, and details can be found on the Stamisol website. So thank you, and I'll hand you back, and hope you found it a certain amount of interest for future buildings and any possible recladding programs that you may have. Thank you.
Thank you very much indeed. I think that was incredibly thorough, and obviously, unfortunately, in the light of Grenfell, I think architects are having to learn that this is not something they can just leave to somebody else. They have to actually ask the questions themselves. I'm going to put one question to you, which I hope you can answer quickly for me, because we are running a little behind time. Somebody's asked, what's the expected lifespan of the membrane behind rain screen cladding?
Okay, the A2 is a lifetime guarantee. The A2 spec is lifetime. The product itself has got a 10-year guarantee, but the lifespan of the A2 is lifetime.
Okay, well, thank you very much indeed for that. So with no further ado, I am going to introduce our next speaker, who is Claire Barton, who is a partner at Haverstock, and she's going to be talking about Tufnell Part Primary School. Claire, you're muted at the moment, Claire. That's it, you're back.
Hi, everybody. Thank you so much for that, Ruth. I'm just going to give a health warning, because in the practice session this morning, part of my ceiling fell down. So we've had a leak for a couple of weeks. So if there's an almighty calamity behind me, then don't worry too much, but I might just go off. Right, okay, so I'm going to talk about Tuffnell Park today, which was is a primary school we completed a couple of years ago. But just as by way of introduction, oh, hang on, I'm not showing my screen yet, am I? Just I'm crazy here. Okay, have we got that? Is that on there?
Yes, I can see it.
Brilliant. Let me just get everybody back up. Okay, so so my name's Claire Barton and I'm a partner at Haverstock. We're almost exclusively a public sector practice now. We do a few private residential houses, but the practice has been going for about 35 years and we're a second generation partnership, but the mantra of public sector has been something that has continued throughout the life of the practice. Lots and lots of people know us for our education buildings and particularly for our special educational needs and disability buildings, which we do throughout from kind of nursery right through to further education, but also we're doing a lot more now in transitional living, so young people that are moving from school into residential settings. But that really isn't the only string to our bow. So we do housing, small scale through to large scale social housing. We do lots of community projects. We do a lot of crematoria, police, and a growing number of conservation buildings. And lockdown has been particularly challenging, I'm sure, as it has been for everybody, but we've had some really interesting projects. We've done a bingo hall in lockdown. We've done a really interesting speculative government building. So we've had a quite interesting time with some really different types of projects. I suppose our kind of strap line within our studio has always been just about changing lives and whatever scale that might be. And that's just something we just hold very dear to us as we're kind of going through all the different elements of kind of construction and procurement, ultimately that's what we're trying to do, change lives for the better. And I think the last couple of years has really taught us the amazing kind of possibilities with collaboration. So we do an awful lot of collaboration now, and that's within the studio, with our clients and with other architects, and we're finding that's a really positive thing. It's very invigorating for us as architects, and we're really pro collaboration. But also with our stakeholders, we're not a practice that wants to sell an iconic building, and we're not a practice that wants to sell a building that belongs to one person in the studio. We're very much about meaningful consultation with the stakeholders and the end users that we meet, and really about how we all collaborate around that building, and it's very much a shared solution. So that is something that's very important to us. And these are just some of the buildings that we've been finishing off over the last few years. So this is one of the crematoriums that we've done, and this one's in Guildford. This is one of our conservation projects in Brackley. This is the government building we've been looking at, and we're in collaboration with Alford Hall Monaghan Morris. We completed New Scotland Yard a few years ago, which is another exciting project. So today I'm talking to you about Tufnell Park, and Tufnell Part Primary School is a really interesting, it's a mainstream state primary school in the middle of Islington. And really interestingly, because we're a public sector practice, we spend an awful lot of time doing bidding. And for those of you that will know about the kind of bidding process in the UK at the moment, I mean, it's a really quite a hefty process. You have to be very reactive to a bid coming out. Then a bid does come out that suits you, and there's several stages of getting through that bid, which is often kind of an expression of interest, and then a kind of pre-qualification questionnaire, then a tender document, and then potentially an interview. And from beginning that bid to kind of arriving at a paid job can often be, 4 or 5 months. So what was really interesting for us about Tufnell Park was that we were working with a contractor. We just finished a couple of schools with a contractor, Morgan Sindall, and they actually asked us to be part of this bid with them. And so therefore we bid together, but it was effectively just one stage. And in our world, that's quite unusual and actually made the process quite easy, and it felt like a bit of a joy to be on the kind of, I mean, obviously we still had to bid for it, and it was a kind of Christmas bid. So it's one of those bids that you're kind of doing till the last minute just to get it in. It was through the Southern Construction Framework, which is quite a popular framework that's being used at the moment. But nevertheless we did it. I think I was working alongside one of the design managers for Morgan Sindall, and all the way through the bid she was talking about this modular building, and I was just saying, I'm really nervous about this. I just think it's just not giving us, maybe we just need to describe it differently. So we had this whole conversation about how we described a modular building, but it was such a big part of their bid that it was important that it was in there. But we went with the term offsite because we felt that there was more, we felt that people had preconceived ideas about what modular was, whereas offsite would maybe more accurately describe what we were going to be doing. So ultimately, the reason this particular project went down that particular route was because we always knew that the school was going to be in full operation throughout the project. So these were just a couple of the buildings. This is Moorland School that we just finished with Morgan Sindall, and this was Dowry, which is the Bridge Integrated Learning Centre, and New River People Referral Unit. They were a co-located school. So these are the projects we just finished. And therefore, I suppose Islington were one of the reasons we were probably successful was that we'd had a really good working relationship with Islington and Morgan Sindall. So it seemed to set us up well for that particular bid. So this is the site, and hopefully you can see can you see my cursor? Is that clear? So this is the existing school here. And this was where we put a temporary school in order for us to be able to build the new school. So the position of the new school is here. And this was actually a temporary school on their site, which allowed us to demolish part of their building in order to build the new building. So you can see it's an extremely constrained site that we were working in. And, you know, the issue of the school being in a temporary building throughout the process of construction was also obviously, you know, something that was quite a major thing for the school, and we needed to work with them all the way through that. And this just gives you an impression. I mean, you know, I have tough working relationships with contractors, but when you see the kind of level they will go to build a school, and, you know, the kind of level of precision and how closely they can work alongside an existing building, you really realise that you're definitely working with top tier contractors that can do this. So effectively, Tufnell Part Primary School ended up being a fully off-site constructed solution, apart from the external envelope, which was completed on-site, and that's just the kind of final brick finish. And we worked with Morgan Sindall and Eco Modular on this project. And Eco Modular pride themselves on being a bespoke off-site component construction. That's how they describe what their product is. And that is because you work with them extremely closely to kind of realize your design. And that's something they're very proud of as a company. And we, their factory is in Hull, and many of you will know that an awful lot of these off-site companies are based in Hull. They have huge factories. And the way that our particular components came to site, and I'll show you some photographs of them arriving to site, was they came internally, they were finished to a painted finish. We could have gone a step further and had them completed with furniture, but in this particular process, we decided to get them to a painted finish. And then from the outside, they were completed to kind of the breather membrane, but all of the windows and doors were in. And I'll talk to you a little bit about why that happened, because that wasn't the ideal solution, but that was the solution we ended up with. And I think as a studio, because we'd worked with SIPs and, you know, other forms of modern methods of construction, but never something on this kind of scale before. You know, it really was a kind of eye-opener to us as a practice. And I think what we were so amazed by was visiting the factory and just seeing the level of quality and the level of rigor around their manufacturing process. So just the efforts they went to reducing waste, the kind of health and safety, how strict they were about manhandling and the size of all the different elements that were going into the component, the kind of sequencing of the trades, how long they spent on every element of the building, how it was set up in the factory, how you walked around the factory, and all of the timescales and programming. I mean, it's a 24-hour operation, so people are just working consistently in shifts through the night, and it really was an amazing thing to see. And from our point of view, every bit of our school is made from these components. And so I'll just give you, I'll just show you some images. So this is the factory. You can see all these kind of coloured markings on the floor. So this is all about kind of working spaces, safe working spaces, how people have to move around the factory, and just the level of, you know, just general cleanliness. Even all the tools are organised in special toolkits, and everything has to go back into the toolkit. Every station has exactly the same toolkit. It really is very impressive. And this is the building coming to site. And you can see it was an extremely constrained site because the site compounds were actually on the road, and you know, you can just see in the corner the kind of porter cabin, which was the temporary school behind as well. And these were just different elements of the whole project coming together on site. So if I just talk you through the actual school design process itself, although I'm not going to dwell on this too much because we want to talk about the challenges of using the offsite process. But it was a 3-form entry school, and this particular project it wasn't being procured through a Department for Education framework. It was actually being procured directly through Islington, which in some ways was a positive thing. But I think, nevertheless, the challenges of working with the Departments for Education's output specification and also working within the space standards of Building Bulletin 103 were very much upon us, and that was the framework we were working in. So while we weren't working specifically for the department, Islington had kind of commandeered all of their standards, and that was what we were expected to do. I mean, we do an awful lot of technical advisor work with the government, so that wasn't necessarily a problem to us, but you know, they're demanding standards, and in terms of space and circulation, they're extremely difficult standards to meet. You know, and there's still a lot of forum about whether they're working or not, but you know, nevertheless they're very demanding. I'll show you the plan so you can see the impact of how the system, you know, where that kind of came up in terms of the plan, and we can talk through the whole solution, and I'm just going to go through the concepts as well. So this was on all our school buildings right at the very beginning. We spend a lot of time with the school. We'll observe schools, we'll spend a day with them, go through all their critical times, drop off, pick up, lunchtime, and just get under their skin to fully understand what they were about. And this, we always kind of try to produce a manifesto that is kind of our Bible as we go through, to keep revisiting it and ensure we've kind of met the targets that we've all been set. And you know, a lot of these, you know, are born out of the educational outcomes that Tuffnut Park required at the time, and how they needed to manage their school in order to to be consistent with their pedagogies. So this is how we would start our process, and then this, you know, obviously transforms into a building at some point. And this particular building, the site has very complicated levels. So the street level is actually at first floor level as opposed to ground floor level. So there's actually a lower ground floor, a ground floor which is at street level, and then a first floor level. So this kind of just gives you, and if I just flick through these slides now, you'll see the kind of level of repetition that the system forced upon us, which isn't necessarily a problem, but you can see how the stacking was working. At the outset, the plan had always been for the hall element to be a traditional element that was built on site, but in actual fact, Eco Modular were very keen to prove that they could do that with their system. I think from our point of view, you know, it's interesting that because it's a solution that doesn't necessarily, I think the idea that all offsite solutions conform to very specific grids is not necessarily true, but I definitely think that you're pushing and pulling in lots of directions. So quite often, in terms of the space standards, you often have to move. We moved above the space standards, not by a huge amount, but that in terms of area, just the very notion of fitting the Lego bricks together did mean that we went slightly off area. But that was something that Morgan Sindler and Eco Modular, you know, they just stomached that as part of their system. And so the cost plan wasn't amended because of that. That was just all part of the process. So these are just a couple of the internal perspectives that we did at the beginning, and just some of the perspectives that we did for the school through the process. I think we're extremely conscious of the way that we represent our buildings with us, with the end users and stakeholders. I think it's really important that they're very accessible and that they can kind of understand you know, the type of building that we're trying to realise for them at the earliest possible times. This was quite an early sketch, but it did give them a sense of what we were doing. And I think, you know,
hi. Sorry, I think you are going to have to start winding this up because you've actually run through your presentation time and your question time.
Oh, sorry, I'm so sorry. So I'm just gonna, these are just the elevations, so I'll quickly go through these. And just so that you know that it was a project that was supposed to be done in timber, but we eventually had quite a lot of issues with the planning, and therefore the conservation area that dictated that the solution needed to be brick. So that's why the solution that actually came to site was only fitted to the breather membrane, and then the brick was actually applied on site, and that did have some implication on cost and program, but still the off-site solution still overall the program and the cost actually benefited. So these are just some of the it just shows you the elevations that we went through. So, you know, from our point of view, we think it's for, you know, we're really for off-site solution because we think it definitely gives a higher quality because of the factory finish. It's definitely robust, so you know, the preconceived ideas about it not being robust just isn't true. It can be bespoke and it doesn't have to look like off-site. Obviously, it is quite a repetitive solution, and that's just a reality of the system. And it's not necessarily cheaper. The contractual management elements of it aren't perfect. And there's an argument to say that eventually, albeit on this project, they needed our support in terms of the output specification and working with the Department for Education standards. There is an argument in the longer term that we're always working with in-house architects at the off-site companies. So there will be, there's unarguably a diminishing role for the architect. And these are just some of the final images. I'm very sorry, I completely misjudged that.
Don't apologise at all. It's been really fascinating, and actually if you have a look in the chat, you'll see there are people who are saying that they want to know more, so possibly you can contact those people. Don't apologise at all. It's been absolutely fascinating, but what we are going to do is we are going to move on without any questions. But thank you. I mean, you've covered it incredibly thoroughly, and it's fabulous to end up seeing a happy and working school. What we're going to do now is we're going to move on to another project, and it is at the other end of the learning process, in that we are going from a primary school to a university. And David Patterson at Make Architects is going to talk to us about teaching and learning building at the University of Nottingham. Over to you, David.
Thank you very much, and good morning, everyone. So I'm going to talk to you today about the teaching and learning building, and I'll start showing my presentation. So hopefully everyone can see that.
Yes.
Fantastic. So this is just a summary of what I'm going to talk to you about today. It's an overview. I think really the first thing I want to talk about is basically Make itself and our studio, and the fact that we have a lot of shared values with the universities and the institutions that we're designing buildings for. We're very people focused. We like to have everyone together in one space. Everyone has the same type of desk. We have lots of sort of like extracurriculum type activities as well in terms of mentoring. And we're really, really keen to understand how successful our design approach has been. And so we commission our own post-occupancy evaluations of completed projects. In addition to that, we run a thought leadership piece. The latest one is about post-COVID, what are the effects on higher education? These are just some extracts from it. We've talked to a number of our university clients and friends. And more information on this can be found on our website, but it's quite an interesting sort of like set of articles. Again, we've got a really good higher education portfolio. We've worked for a number of fantastic universities in the UK, including Oxford, Nottingham, and York. And the Teaching and Learning building is our 6th building for the University of Nottingham. So these are just some key data about the project. And I'm going to go straight on and talk about the university's vision. Now, the university had commissioned probably about 10 years ago a global strategy about where they wanted to be positioned by 2020. And I know a number of speakers earlier on this morning have talked about this. And what was really sort of like different about their approach was the fact that they really wanted to place students at the heart of everything they did, which does often sound quite obvious, but I think that was a real step change for them. And this building that we've designed for the university was in response to that sort of like overarching vision. This is a view of the site prior to starting the project. You can see the Hallwood Library there and a number of mature trees. So the site's like very, very constrained. There's lots and lots of very noise sensitive activities happening around it. And it's very important, obviously, when we're designing these buildings to make sure that we are minimizing the impact on the students who are actually there, who may not benefit from this building, impact on their adversely on their experience. And then this is the building on the site. So I think fundamental to our design approach was making sure that we plugged into the campus and we understood how people were moving around the campus. The Teaching and Learning building is a centrally timetabled building, so no faculty has ownership over it. But what was important was it is literally positioned at the heart of the University Park campus, and it needed to be accessible from all orientations. So we spent a lot of time understanding how people moved around the campus and making sure that we actually had entrances, multiple entrances positioned where people really needed to enter the building, and then they converged on a central courtyard. Stakeholder engagement is a huge part of what we do in terms of developing the design and the brief with the university. And what we always try to do at the start of a project is develop a flexible diagram, which we can adapt and modify through the design and briefing process. So again, these diagrams here are just talking about how we laid the building out to respond to routes, how we adapted it to respond to topography and surrounding buildings, and then how we started thinking about creating a modular approach. So the sort of like the key overarching concept here is we were creating volumes of more formal type seminar and teaching spaces with more fluid, open, less programmatic social learning spaces surrounding those. And again, this diagram sort of illustrates that point. We sort of like we're trying to illustrate to the university the hierarchy of different types of learning environments that the building needed to provide. And again, I've mentioned stakeholder engagement. We spent a lot of time working with all different user groups, obviously including students, the student union, academics, library services, to really understand what the needs were for the building and how people were planning to use it. I think what really came out of that whole discussion was the fact that teachers and students wanted space which they could adapt and modify to their needs. And I'll talk a bit more about that in a bit more detail as I talk about the design. So our design was to really create like a really generous spatial structure. So there was some rigor and organization to the building, but it could be adapted and modified depending on how people wanted to use it. So you can see here, this is the central atrium space. You can see lots of use of the surrounding campus. This is the open plan area, which is for like group and informal study work. And again, it was really, really important to us that the building was accessible and welcoming and inviting. And that's also important in terms of like welcoming the local surrounding communities to this building as well as the students, and making sure that people felt invited into the building and actually enjoyed being there. So I'm just going to summarize some of the key characteristics of the building. So firstly, we were really keen to have a very, very concise and durable palleted materials for this building. I mean, this building is obviously essentially timetabled, has incredibly high footfall. So you have over 2,000 people potentially arriving and leaving over on the timetable switchover on an hourly basis. So whatever we were looking to specify for this building needs to be very robust, durable, and economical for the university to maintain. So that really led us down the path of having really self-finished materials. So the predominant material is CLT, so it's timber, it's exposed timber everywhere. And then we have a glazed external terracotta tile. And at the lower levels where we need it to be really robust with lots of footfall, it is an architectural masonry block. We were really keen to exploit the fantastic potential of the surrounding campus. So I don't know if people are familiar with the University Park campus in Nottingham, but it's like famous for its really mature and beautifully maintained landscape. And obviously we're particularly lucky around this site to have these amazing mature cedar trees. So that really helped inform how we designed the building in terms of exploiting views and sort of like in more informal study areas and how they're related to that. And again, making sure again that we had the right balance of daylight and natural light, so not to compromise people when they were working. And again, we were really aiming to create space that felt open, it felt safe, and it felt functional for people to use throughout the day and throughout the year. Acoustics, because we've got large volumes and there's a lot of open plan space, we're critical because you've got areas where people are being noisy next to areas where there's lots of quieter study and reflector study happening. So again, we spent a lot of time making sure we had all the right acoustic ratings, the right acoustic absorption to make sure that we were able to control the acoustics and create the best sort of like acoustic environment for teaching and learning. Another key aspect of the building was to make sure that we provided flexible and adaptable spaces that could be adapted over the academic year, that the university could utilise over the summer holidays for other uses, for conferencing, and to make sure that it also supported more traditional educational practices. This building does have a lecture theatre and it does have a number of seminar rooms, but the large majority of it is more fluid, unprogrammed space, lots of spatial variety for students to use in lots of different ways, rather than adapting and moving and changing walls and moving furniture around, which we felt wasn't going to be a very satisfactory solution. Again, all the spaces converge on this central atrium, and the idea is that's to promote social interaction and also visual connection between people as they move around the building. Sustainability was almost like a fundamental part of our design approach. The building is BREEAM Excellent. Our kind of approach to this was almost like a passive design approach. So it's obviously fabric first, create a really high performance facade and natural ventilation wherever we could. So we're using the atrium to ventilate the building, taking advantage of the stack effect. So stale air is drawn through the formal teaching spaces, through the atrium and exhausted out through the roof. We've also tried to maximise the benefits of on-site energy renewables by using photovoltaics. We spent a lot of time thinking really carefully about the quality of natural light and making sure that we had the right amount of it to minimise glare. Again, delivery, the budget for the building was ambitious. It's a large building and it was delivered for £2,500 per square metre. And part of the whole delivery process really for the building was benchmarking it against other completed higher education buildings. So we went with the university to a number of buildings and worked out with them what they thought was good value for money and what wasn't such good value for money. And then the building was designed in BIM. It was one of our earlier BIM projects, so it was quite a steep learning curve for us. We weren't asked to produce it in BIM, but I think the benefits were really great for us because we were able to obviously design everything, coordinate everything. All the steelwork's exposed in the building, all the masonry is exposed, so it's pretty unforgiving if it's not very well coordinated because we can't hide it with dry lining. So that really paid dividends to us in terms of like investing that time in developing the BIM model for the building. Again, we really focused on modular construction. So we tried to use everything as one module. We had one window type. The masonry was stack bonded. So that meant we were just like minimizing cutting and minimizing wastage. And again, as I mentioned, we really wanted to exploit sort of like modern methods of construction, so CLT, which is all factory finished, and then taken to site, installed, and again, minimizing disruption to the students and the surrounding academic buildings. So in summary, we were really, really proud of the fact that we were able to manage like a very, very broad range of stakeholders to define a consolidated brief. I think what's been really successful, we've commissioned our own post-occupancy evaluation for this building. And what's been really successful is the fact that users have picked up on the fact that they really enjoy the ability to move around the building during the day and study in lots of different environments, depending on what task they're doing. And all of them have picked up on the fact that they really enjoy the quality of natural light and ventilation, and the views to the inside and outside of the spaces. So I'm going to leave it there and take any questions. Thank you.
That's fantastic. Thank you very much. I think it's interesting that obviously, I presume you saw Claire's presentation before yours.
I did.
And she was talking about sort of taking modular construction very much to the extreme. I think you're talking about modular construction as well, but it wasn't at quite such a strong level. It certainly wasn't volumetric, was it? But did you feel anything was constraining you?
No, I think it was a really, really useful constraint because I think with the sort of like the budget pressures that we had, minimizing lots and lots of different types of interfaces and lots of different types of components was a really, really useful constraint when we were designing the building. And it really did help when we were building it. Helping the contractor understand what they were doing with it as well.
That's fabulous. And I suppose the other question I can't help asking you is how you feel now, given the way that that all universities have had to operate so differently. Do you think there is anything you would have done differently if you'd known we were going to go into a pandemic?
That's a really, really good question. Thank you for asking me that. I think what's really interesting about that was the university's vision that they sort of like wrote 10 years ago, in a way preempted what was going to happen with the COVID pandemic, because there was already a trend for digital learning and more social learning and self-guided learning, and less on sort of like knowledge transfer and then much more of a focus on knowledge exchange. And I think from our thought leadership pieces that I mentioned earlier on in the presentation, that has just been accelerated by the pandemic, maybe through necessity.
Yes.
So I think this building, they've still been able to use it during the pandemic. They've been able to use it at lower densities, so it's still safe to use. I think a big benefit with it is the fact that it is naturally ventilated, so it's easier to keep the internal environments full of fresh air, which is kind of one of the requirements for the pandemic as well.
And we've all learnt to wear coats indoors, haven't we?
Exactly, yes. Yes, and get used to the
very
cold.
Very environmentally friendly, isn't it? That's an absolutely fantastic presentation. Thank you very much. And we're going to get on to our final presentation, which is coming not just from one, but from two people, the founding partners of RIBAJ Architects, who are Anthony Boulanger and Yoye Manolopoulou. They're going to be talking about Eleanor Palmer Primary School in Kentish Town, which must be just down the road from the Haverstock project that we saw. But anyway, over to the two of you. And it's the last presentation, but it's one I'm certainly very much looking forward to.
Oh, thank you very much. Yes, it is. It is just around the corner. We're within walking distance of the projects. We walk by them daily, in fact. So I will be giving. My name is Anthony. I will be giving the chat myself. Yuria is here, but because of the length of the case study, it'll be myself. I'll just share my screen. Just one moment. Okay. Great. Wait a second. Oh, that's interesting because Zoom is hiding my notes. Okay, here we go. Okay, so yes, thank you very much for coming, everyone, for tuning in, and thank you to RIBA Journal for inviting us to give this case study on what is a very small project compared to the others that we've seen this morning. So I'd just like to start to put the project in context. Our practice is based in Kentish Town, London, where we live, and our work with schools to date has been mainly with those schools in the area. We have 3 children now, pardon me, and they're in secondary school, and our projects have followed them from school to school. Our first realized education project was Montpellier Community Nursery. That's pictured in the top left-hand corner, where our children started. And after we had just moved into the area, then a small freestanding library space at Toriana Primary School in the lower left-hand corner. And then subsequently, and most recently, 2 extensions at Camden School for Girls on the right-hand side. The other scheme at the bottom is a competition entry. This does not fall into that category for a primary school in Dublin. And Eleanor Palmer Primary School is also an exception to our rule of following our children. Our children didn't go to this school, but it's a neighboring state school in the immediate area. Eleanor Palmer Primary School is, they won a local authority grant to extend the STEM curriculum, science, technology, engineering, and maths, across the borough of Camden. The school's drive for the project came from an extraordinary experience by the whole school community to speak live to astronaut Kjell Lindgren on the International Space Station in 2015, in November of 2015. And subsequently, we were appointed for the project a week after this unique conversation. So this photograph shows what most people see of the school, or saw of the school. It's a high boundary wall fronting Fortes Road. The level of the school playground behind the wall is about 2 meters higher than the street level, and the school entrance is on a small road on the other side of the site. The location of the new science lab was almost predetermined on the site, and it was an underused Victorian canopy structure sitting up against the boundary wall, and you can see it here in the previous slide. The structure was one of the very few things you could actually visibly see, aside from the boundary wall itself, one of the remnants of the grand Victorian secondary school that once stood on the site, but of very little value to the school. So the school's vision was to create a dedicated space that would allow exploration and inspire young minds rather than a primary version of a secondary school science lab. So we started to think of this as if we were designing a learning environment to foster inquiring minds, a curiosity, and wonder in the world. So a wonder room, a treasure house, and a place for discovery and experimentation. And so we were inspired by this well-known drawing of Olaus Worm's museum from 1655. It was depicted as a cabinet of curiosities. So we began with the school an iterative design process focused on how the building's own physics can create an environmentally conscious classroom. The first sketches are quite ambitious in all that the building could provide for the school, including a mezzanine for storing experiments and artifacts, and a sky room with a retractable roof light for stargazing, or to see the space station whiz by, perhaps. And the school was also keen for the building to improve its relationship with the main road and the surrounding community. Many people in the local area had no idea about what lay behind this high wall or had any view of the school's creative ethos. So the building almost became a kind of vehicle to help form this new connection. So in designing the project, we made more than 30 physical models to test the initial design options. And we worked closely with an advisory group made up of teachers, staff, pupils, and parents. The pupils were called the lab rats. It was an acronym for something I can't quite remember, but they were a fun group to work with. So the first design concept was quite ambitious, and this included the mezzanine, archive, and the sky room. You can see this, the skylight. This was tested with planners, and they said the scale was too large. And this was supported by the QS, who said it was too expensive. So the design evolved, but the key design elements and important passive design, environmental design principles that were established at this early stage remain throughout the entire design process and are evident in the finished building. So the key elements of the design were to showcase the lab stations and their activities and its equipment inward towards the school. It was also very important to create a high space for carrying out experiments and hanging children's work. And we wanted to create this visual connection through the boundary wall. We had already started working with environmental design consultants, Ritchie and Daffin, to develop a passive design strategy that worked within the site constraints. So the core principles of that were to create good natural daylighting conditions with north-facing openings in the roof, interactive ventilation during all seasons, while shielding from the noisy road. So we explored a timber frame construction from the very outset on environmental, aesthetic, and economic grounds, collaborating with structural engineers Price and Myers on developing a design based on using standard sawn timber elements. This model shows that initial iteration and how the timber structure would be designed, or at least an idea for that. This is an in-between iteration of the design prior to the final design, where the building shrunk to a single story with a higher extruded triangular volumes. These volumes shown here were 3 at the time. This was a simplified approach to providing desired internal height, bringing in ambient daylight through the roof, and the extruded triangles would also reduce the impact of the building as seen from the street, addressing planners' initial concerns. The presentation for the planning submission shows a reduction of the volumes down to 2 with north-facing roof lights. Here you can see them, and the puncture through the boundary wall. And the view of the design as seen from the school fronting the playground. The strip of windows runs along the lab station, so you can see the science activities from the school. That was very important. So the triangular volumes popping above the single story were experienced quite differently as you pass by the building on Fortress Road. And this is a sketch showing that we produced for planners. It shows a simulation of the volumes and was used for negotiations on the massing of the planning submission. Sorry for the background noise. Our neighbor decided to do some building works all of a sudden. So the primary and secondary structure consists of sawn spruce beams, columns, and joists in standard sizes with quite simple detailing for the timber connections. And this is a drawing as a summary of that we gave to the structural engineers, to Price and Myers. So the plan, it's a very simple, single, flexible space with children lab stations along the playground side and storage aligned with storage internally, a single toilet and a storeroom on one end. That the storeroom also acted as a dark room. The upper floor shows the north-facing roof lights and the vents, high-level actuated vents on the east facade facing the school that sit behind the external cladding. The vents are controlled by an air quality sensor that children can see in the classroom. The section quickly just shows the level differences from the street to the classroom to the lab, and the puncture, the deeply punctured window as a display window to the street. So just after getting on site, the project came to a rather abrupt stop. when the contractor realized that the existing Victorian shelter was actually restraining the boundary wall and preventing it from possible collapse. The length of the boundary wall had been underpinned already by the council a few years prior, but to questionable effect. So securing the boundary wall was a major task, and that took a few months. And part of the upper section of the wall had to be rebuilt and became timber clad to tie into the building. In addition to this, excavations revealed that for the foundations, revealed that there were hidden structures, Victorian structures, below the site, and the site is built up ground, which was never really apparent. So the foundations needed to become much deeper. So this all caused significant delays to the project. But we finally started to erect the frame, and the frame, this is just an image showing how the frames of the building acted to restrain the retained section of the boundary wall where the building was. So we understood the project to be a pioneering model, a new building typology dedicated to teaching of the sciences for nursery and primary school pupils. And from what we understand, this is the first of its kind in the UK. The internal space is lined with walls of built-in furniture, of spruce and birch-faced and formica-faced plywood. The atmosphere is like an elaborate garden shed with the smell of wood. The display cases host a growing collection of specimens and objects brought in by the school community, and the lab is a shared resource with other schools. Here you can see the north-facing roof lights and the vents. So this just shows a technical drawing of the unpacking of the internal elevations, the lab station, storage, and structure. The timber structure is a teaching device engaging children with geometry and technology. Children are able to unpack and analyze the parts of the building intuitively. The front view from Fortis Road, where you can also see the rebuilt section of the boundary wall and the north-facing roof lights and our vitrine onto the street. The external cladding is a thick profiled Siberian larch rain screen. The cladding is closely spaced at low level to accept impacts from the playground use and to prevent small fingers from getting trapped. The spacing becomes wider at high level to allow a lighter effect and airflow to the concealed vents behind. We also created a bench along this elevation facing the school and the playground for children to sit. And there are also these bifolding doors which allow the activities from the science garden, from the science lab to spill out onto the playground. This is just an exploded axonometric drawing showing the elements of the building in context. And this drawing also shows the location of the science garden at the north corner of the site. Here we collaborated with the practice unit lab, who created an anamorphic playground. So play equipment that plays with perspective and visual distortion. That's here, quite unusual objects. And we also worked with electric pedals, who made a school disco powered by 2 bike generators, which was a huge hit. So this is an image of the giant astronaut's helmet sitting in homage to the astronaut Kjell Lindgaard, the school's inspiration for the science lab. And I'd like to end by showing a short film we made when revisiting the school to record its habitation. Hopefully this plays. Yes.
Hello, Kieran and Martin and anybody else listening in on the World Wide Web to this incredibly exciting moment.
NA1SS, VK 6 mics of it. Over.
Oh, snap!
Because I normally put stuff on the website.
You and Alex in Fuzzy.
rocks have a minimum age of 3.77 billion years, but some scientists...
It looks like a snail shell. Yeah, I think it might be. Look, it's got some tiny rocks in it. And there's some more here. I like the purple one the best. But I find this one a bit. Yeah. 1, 2, 3, 4,
And good morning to the students of Eleanor Palmer. I'm delighted to be speaking with you this morning. So many teachers inspired me to pursue my dream.
So that's how it's going to work. Once you're happy with yours, you can then make the box.
Hi, this is Natasha, and my question is, does being in space make you feel differently about Earth? Over.
Yes, Natasha, great question. You know, when I look down at the Earth, and I think many astronauts, when we look down at the Earth, we don't see borders. We just see these beautiful continents surrounded by water. It also gives me the sense that the Earth is really a big blue and white spaceship. Just like we take care of our spaceship, the International Space Station up here, that we really need to take care of the Earth as well. Over.
Thank you.
Well, thank you. That's a fantastic project to end our morning on. We've got people in the chat saying things like fantastic, lucky children, and that was actually before they saw the video. So I'm going to give you one slightly technical question. Somebody says, hi, Anthony, interesting design approach. Was there an opportunity to have the roof peel over the exiting wall, allowing curiosity?
That's an interesting question, because our first design ideas involved the roof just hovering above the wall with a strip window that would illuminate this gap between the building and the wall. But we decided, I think, for cost reasons, and also because of planners, they were quite tough on reviewing the height of the building and its relationship to the street and its prominence. So that's something that, through a combined number of forces, was reduced and designed out from the first stages.
I think it's an absolutely fabulous project. Oh, here we are. Someone's saying this school lab brought a smile to my face. What a lovely project. Thank you for sharing. And I suppose the one question is, you know, when you say that you believe this building is the first of its kind, have you had any approaches about doing anything similar anywhere else? I realise that wouldn't benefit your children, but
we haven't actually. It's a unique situation, I think, where a primary school is able to build a freestanding lab as a kind of retreat within its own grounds. But we'd be very happy to be asked to do another one or two. So get in touch if you'd like that, if you need one.
I don't think I'm in the market. And anyway, presumably in a few years, you're going to be designing university buildings, aren't you?
We hope so.
You hope so. Okay.
If we continue our path, yes.
Your trajectory, yes. Well, I think I really enjoyed that, and I can see from our audience that they really did. And in fact, we're getting great feedback on the whole event. Paul Middleton saying, excellent presentations across the board. Well done, everybody, including RIBAJ Journal, for organising. Since I'm actually slightly outside the RIBAJ Journal, I can say exactly the same thing as well. The presentations will be available, or at least the video will be available. If you've looked in the chat, you'll see that you will be able to get hold of this. And I know some people wanted to be able to see this in more detail. The presentation that we had from Paul Stallan, as he said, you know, there's a, sorry, not from Paul Stalin. The presentation we had from Allan Hurdle, there is a more detailed CPD available if anybody wants it. There's the opportunity to buy Ron Bakker's book, but I think almost we just need to go away and digest this. It has been difficult times for education buildings, but we have seen here some absolutely fantastic things coming through. And I would concur with Paul Middleton that we should thank all our speakers. Some of them are no longer actually present, but obviously without them and without their excellent skills and the fact that they battled through Wi-Fi problems and even a collapsing ceiling, we could not have had this fabulous morning. I also have to thank all of you for attending, because if you didn't, there would be very little point. And for your questions and for your chat, where there's been all sorts of things going back and forward between you on, you know, the value of electric cars and goodness knows what else, which I think just goes to show that this has been a really thought-provoking morning. So I'd like to thank you all very much again for coming, thank the organisers, thank the speakers, and I think it's now time for you all to get on with whatever other things you've got to do. But don't park this, because I think it has been so exciting. And well, I hope to see you all again next year, when I'm sure there'll be an equally exciting programme of events. So thank you very much. I'm going to close this and say goodbye now. Bye.